Hello and welcome to the Intro to Geotechnical Soils Lab. My name is Gretchen and today we're going to be learning about Atterberg limits and moisture content determination. Atterberg limits are the moisture content or threshold water contents at which certain types of engineering behavior can be determined or expected. They're the change in consistency with a change in moisture content. So there are two specific moisture contents that we're going to discuss, liquid limit and plastic limit. The plastic limit is the water content at the division between the semi-solid phase and the plastic phase. Above the plastic limit, the soil begins to exhibit plastic properties. And then the liquid limit, it's a higher moisture content, is the moisture content at the division between the plastic phase and the liquid phase. Above this liquid limit, the soil begins to exhibit liquid properties. The relationship between the two is the plasticity index, and that's one of the most important concepts that's utilized in soil classification and in constructability of soil. The equipment that we utilize to run these tests consists of, for the plastic limit test, we have a glass plate. There's a smooth side of the glass plate and a rough side. You always want to make sure you're using the rough side of the glass plate. A plastic limit rod. This rod is a 3.2 millimeter diameter. It's utilized for the technicians or students to ensure that their plastic limit threads are the right diameter. And then moisture tears or moisture tins to put their samples in, to put in the oven. And then bowls for their soil samples. And a water bottle. And a spatula for mixing. And a scale. And then for the liquid limit test, we have the same equipment, a larger bowl because it requires more water and more samples. And then we have a Casa Grande device that consists of a hard base, a brass cup. There's rubber feet under here. It's named after the gentleman who developed the testing procedure. And then a grooving tool. This grooving tool is used to cut a groove in the soil plate or in the soil pat, I apologize. So these two tests, the plastic limit test and the liquid limit test, are run on only fine-grained materials, on the material that passes through the number 40 sieve. So the soil for the experiment will have been prepared in advance. So it's prepared for the students. It's been dried out. Now, no soil is completely without moisture. There will be some unknown amount of moisture in it, but it's relatively dry, and it will have been passed through the number 40 sieve in preparation for the experiment. So the first test we're going to run is the plastic limit test. For this test, we'll get 20 grams approximately of the material that's passed through the number 40 sieve. The students will moisture condition this soil to approximately the plastic limit state. Once that soil has been moisture conditioned, we'll place it on the glass plate and attempt to roll it into the thread. We will take the moisture tear and weigh it empty. Record that on the lab data sheet, empty. Put the threads in it, and then weigh it wet and record that. Then it will be placed in the oven overnight. Students will come back the following day to weigh it dry. And then with that information, they can calculate the moisture content. The wet weight minus the dry weight divided by the dry weight minus the empty weight times 100 to convert it to percent gives us our moisture content. Okay. All right. Nafisa is tearing out the bowl on the scale. So now the scale reads 0, so she can determine exactly how much soil she's putting in the bowl. Okay? So the scale reads 0. She's going to put in approximately 20 grams to run the plastic limit test. She doesn't need to record this weight anywhere on the data sheet. This is just an approximation to ensure she's got enough soil to run the test. Now she's going to take this soil and moisture condition it. She's going to add some water and mix it. The spatula is provided for ease of mixing. You can mix it with your fingers if you would like to. It's very, very wet. That soil has reached its liquid state, so she's going to add more water or more soil to dry it up. As you're mixing, you need to ensure that you've mixed it until the soil is homogeneous, which means that it all looks the same. If any time you're running a soil test and the soil is not homogeneous, your results will be inaccurate, so you need to continue mixing. So the plastic limit, as you will have read about in your lab manual, is when the soil is just beginning to bind together. So it won't be like Play-Doh, it needs to just barely be binding together. So Nafisa's still too wet, and she's going to have to dry it up. So now Nafisa's mixing it with her hands. Clay really requires a kneading action for mixing, so she's using her hands to mix it. That's why she's got the gloves on, so she doesn't get dirty. Now she's transferred it over to the glass plate, and she's going to roll it into a thread. Again, the target is to roll it into the 3.2 millimeter thread where it forms cracks. So if she can get to 3.2 millimeters and it's not cracked, then the soil is beyond the plastic limit and needs to dry. If it cracks before it gets to 3.2 millimeters, it's too dry, it's in the semi-solid state, and it needs more moisture. So as Nafisa's rolling out the thread, she's trying to get to 3.2 millimeters, or 1/8 of an inch. She's taking care to see how much pressure it takes. That's the toughness that we've discussed before about how much pressure or toughness it is. It's an indicator of the plasticity. If the soil makes it to 3.2 millimeters and has cracked, then it's at its plastic limit. If it gets smaller than 3.2 millimeters and has not cracked, it's in the plastic phase and is too wet. If it cracks prior to getting to 3.2 millimeters in diameter, it's too dry, it's in the semi-solid phase. She's using the plastic limit rod to compare her diameter. Okay, she says she's happy with it. So if we look, we're looking for the cracks. See how it's created cracks? She's reached the diameter she's looking for, and she's got cracks in it. So that's an indicator that it's at that limit between the semi-solid and plastic state, because it's cracking. So now that she's determined she's at that plastic state, she's going to cut it up into some threads It needs to be small enough to fit in the moisture tear. She's going to take the tear. The scale is at 0. She puts the tear on the scale, and this is going to be recorded on the lab data sheet. Every moisture tear has a identifier number on it. She's going to record that specific identifier number with the empty weight. Once she has that information recorded on her data sheet, she'll then take her soil at the plastic limit, place it in the tear, ensure the scale is returned to 0, place the tear with the wet soil in it on the scale, and record this on her lab data sheet in the tear plus wet soil column. That tear is removed and then placed in the oven. The samples are cooked overnight in the oven at a temperature less than 120 degrees Celsius. Because these soil samples are so small, they're very susceptible to temperature. The students will return the following day at a prearranged time that's been set up with their lab instructor to weigh the samples after they've dried out. That information will be recorded on the lab data sheet in the tear plus dry soil column. So the day following the experiment, students return and get their dry samples out of the oven. Just like weighing the wet samples, you ensure that the scale is at 0. Place the tear on the scale and then record your weight. Again, making sure that the weight is recorded in the tear plus dry soil column. Now that we have all of our data, we can calculate the moisture content. Again, the formula for that is the tear plus the wet soil minus the tear plus the dry soil divided by the tear plus the dry soil minus the tear empty. All of that multiplied by 100 to get our moisture in a percentage. That moisture content is utilized for all of our liquid limits and our plastic limit. While those numbers are not typically reported as a percentage, that is what they are moisture contents or moisture percentages. For the liquid limit test, it's the same soil. We'll gather approximately 100 grams of that material, and each student will prepare one sample of that material. Per the test method, there are two different ways that the test method could be run. Either you should run, this is hard to explain. You should either take 25 blows to close the groove, or you can do a 3-point method where you have a variety of blows and then average those. So what we do is we divide it up to where you can do a sample where it takes 15 to 20 blows to close the groove, 20 to 25 blows to close the groove, 25 to 30 blows to close the groove, and 30 to 35. Because there's usually 4 students per group in our experiments. And then each student will do one of these ranges. This is the brass cup with a soil pat in it. This is the groove that's cut through the soil pat. When you turn on the Casa Grande device and it causes the soil pat to close for a distance of 13 millimeters. The counter on the Casa Grande device counts how many blows that is, and when it's fallen within one of these ranges, you gather a sample, and just like the plastic limit device, you've recorded the weight of the tear empty. Then you put the wet soil in the tear and record the weight wet. put it in the oven overnight, come back the next day and record the weight of the tare dry, and do the exact same math to calculate your moisture content. In this, the only difference in this method is that you'd have the various soil samples. The students in the experiment are provided with a data sheet to record all of their observations and data gathered throughout the experiment, as well as instructions on how to plot the data and what to include in their laboratory report. As part of the laboratory data report at the end of the experiment, students will calculate and plot their liquid limit. On the x-axis is the number of blows that they've recorded. I want to note that the x-axis needs to be logarithmic. On the y-axis is the moisture content that they've calculated. Students will then go across and find the 25 blows, because that is the liquid limit. They'll go up and find where that hits their line of their 4 data points, and then come across, and that moisture content is the actual liquid limit. That's it. Now we're going to do the liquid limit test. So we're going to use the larger bowl for this because it uses more soil. Just like before, we're going to place the bowl on this scale, and then we're going to return this scale to 0 so we can ensure how much soil we have in the bowl. Nafisa's done that, and now she's going to place approximately 100 grams of soil in the bowl. Just like before, this number does not need to be recorded anywhere on your data sheet. It's just so you know you've got enough soil to run the experiment. She's aiming for about 100 grams of soil. Nafisa's going to moisture condition this sample. She's going to add some moisture to it. She's aiming for getting dry of the liquid limit. The driest point takes approximately 30 to 35 blows to close the groove. A good guideline for what is approximately 30 to 35 blows is it looks like frosting. So if your soil is brown, like Nafisa's soil is, add water until it looks like chocolate frosting. Just like before, Nafisa's going to stir it until it is homogeneous, or all of the soil looks the same. Nafisa thinks she's about there, so now she's going to put it in the Casa Grande device and try. She's going to use her spatula and spread it from one side to the other. She's pressing down to remove all of the air voids from the sample so she gets a valid test. Once she's happy with it and got it smooth, she's going to take the grooving tool. She's going to make sure the bevels are facing her, and in the middle of the brass cup, she's going to remove a groove of soil from the soil pat. The Casa Grande is going to tap that brass cup on the base at a rate of 1 to 2 taps per second. Okay? Mixed up and it looks homogeneous. So now she's going to place the soil in the brass cup. She's going to spread it from the left side to the right side, making sure the soil completely covers the Casa Grande device from one side to the other. As she's spreading it, she's pressing down to ensure that all the air voids are removed from the soil pat. Then she's going to use the grooving tool with the bevels facing her in the middle of the brass cup. She's going to cut a groove through the soil pat. She's going to turn on the Casa Grande device. It drops at a rate of 1 to 2 blows per second. Nafisa counted how many blows it took. She's using the base of the grooving tool to measure that it closed for 13 millimeters. It did, so she's going to take her moisture tare, return the scale to 0, place the tare on the scale, record the empty weight on her lab data sheet, use her spatula to gather a bit of the soil from the brass plate itself. She's not going to go back to the bowl. She's going to use the soil that actually comprised the test. She doesn't need all the soil from the brass plate, just a little bit of it. Place it in the tare. Record this weight in the tare plus wet soil category on the lab data sheet. And then that tare can be placed in the oven as well. Just like the tares with the plastic limit, this soil will be dried out overnight at a temperature less than 120 degrees. It will be weighed the following day along with the plastic limit test results and recorded in the tare plus dry soil column on your lab data sheet. The following day, when the student shows up at that prearranged time, they will record their tare plus dry soil weight. That weight will allow them to calculate the moisture content. It's the exact same formula that they utilize to calculate the moisture content for their plastic limit. The last test run in this experiment is a natural moisture content. It's the exact same steps. You record the weight of the soil wet, place it in the oven overnight, record the weight of the soil dry overnight. It mimics just a natural moisture content of a soil sample when that's all you're doing on a soil.
When determining the liquid limit, the first thing you're going to do is plot the 3 various moisture contents that you've tested. So you can see here on our screen, we've plotted 1, 2, 3 moisture contents. You connect those 3 moisture contents into one line. Here we're calling that line the flow curve. After you've plotted your flow curve, you're then going to find 25 blows. You trace the 25 blows up to where it connects to the flow curve, and then trace that over to your moisture content. The moisture content at which 25 blows occurs is your liquid limit. So for this flow curve that we've just plotted, the liquid limit is 42. So the liquid limit again is the moisture content at which it takes 25 blows to close the gap in our groove.